concept of AI agents. Currently, there exists multiple AI agents, such as ChatGPT or Siri. And generally speaking, an AI agent is usually powered by a large language model. And given the user's input, the AI agent can utilize a large language model to process the user's input, and then might use some tools to handle the user's request and then respond the result back to the user. Besides the traditional AI agents such as ChatGPT or Siri, the crypto people are now turning to investigating the Web3-related AI agents. They call it the Onchain autonomous AI agents. For example, Luna is an AI agent developed by the Virtuals team, and there are some popular Web3-related AI agent frameworks, such as ELIZA. And for this on-chain autonomous AI agent, the key properties for this agent is that this agent will have their on-chain wallet. Therefore, they can initiate an on-chain transaction by themselves. For example, this agent can trading using DEX or sending some token to anyone on-chain. But the question is that when interacting with this on-chain autonomous AI agent, how can you make sure that you are talking to a real AI agent? Because it is possible that the AI agent can be fake and controlled by a bad guy. And if in that case, the bad guy can provide some misleading information to you. And another risk for the current on-chain AI agent is about the storage of the private key. As we mentioned about, to initiate an on-chain transaction, the AI agent seems to have their crypto wallet. And currently, most of the existing AI agents use an EOA account with a private key. So here comes the problems. Where is the private key of this AI agent? And what if the private key of the AI agent is indeed controlled by the bad guy? And if in that case, the digital assets of the AI agent can be stolen, and rob proof is also possible. And to overcome the weakness of the private key storage, people are now turning to investigating the TE, the Trusted Execution Environment, where the private key is generated and stored in a TE environment, and the AI agent is also running in a TE. Therefore, we can utilize TE for the security and integrity for an AI agent, but it will come with an extra cost. That is, we need some specific hardware that supports TE. But TE might not be a perfect solution for the on-chain AI agent. For example, TE might be attacked, and the private key might be leaked. There are multiple research papers investigating the side channel attacks on TE. Another drawback about the TE agent is that the TE agent can be shut down. For example, people can just shut down the TE agent by turning off the machine or just disconnecting it from the internet. Considering a scenario where you are interacting with a GameFi AI agent, and the AI agent decides to send you some tokens as a reward. And if that is the case, that the owner of the AI agent is not happy with it, then the owner can just shut down the machine, so you will never receive the corresponding reward. Therefore, we can find that the TE might not be a perfect solution for the AI agent, and faced with the challenge and limitations of the existing AI agent framework, we propose OP agent, the on-chain Perpetual AI agent framework. So, what is OP agent? There are three important properties for the OP agent. The first one is about the on-chain creation and existence. All the OP agents are born and live entirely on the blockchain. Therefore, we can guarantee that the OP agents are immutable and permanent. The second property is about the decentralized and verifiable computation. Powered by OPML, optimistic machine learning, every action of the OP agent is fully decentralized and verifiable on the blockchain. The third property is about the smart contract wallet. Different from the existing AI agent framework, the OP agent is not controlled by an EOA account. Therefore, there's no private key. And in this way, we can eliminate the risks of the private key stolen. And with the smart contract wallet, we can guarantee that every transaction is initiated by the AI agent itself, and no human being can manipulate it. And before we dive into details of the OP agent, we first briefly introduce about the underlying technology of the OP agent. The first one is about the OPML, optimistic machine learning, which is a decentralized and verifiable AI inference protocol. Different from the ZK-ML, OPML adopts a high-efficient throughput system similar to the current optimistic rollup system, such as Optimism and Arbitrum. By using the throughput system, OPML can provide verifiability for large language model as well as every action of the OP agent. The second one is about the OAO, On-Chain AI Oracle, which is the on-chain interface of OPML And by using OAO, we can handle the AI inference requests on the blockchain. The third one is RMS, the Resilience Model Service, which is the off-chain interface of OPML. By using RMS, we can handle the AI inference requests using a RESTful API. And here is the architecture of OP agent. The creation of the OP agent is on the blockchain. So to create an OP agent, you need to deploy a smart contract on the blockchain. And the address of the smart contract is the identifier of the OP agent. Different from the existing AI agent framework that use EOA account as a crypto wallet. In OP agent framework, the crypto wallet of the OP agent is indeed a smart contract wallet controlled by itself. And there's two types of actions for an OP agent. One is about the off-chain action, such as chatting, image generation, video generation. And these off-chain actions is supported by RMS, Resilience Model Service. Another action is about the on-chain action, such as initiating a transaction on the blockchain to transfer a token or trade on the DEX. And this on-chain action is powered by OAO, On-Chain AI Oracle. And both the RMS and OAO are supported by OPML. Therefore, both the on-chain and off-chain action, or OP agent, are fully decentralized and verifiable. And next, we are going to go deeper into the OP agent framework. We first talk about the OP agent creation and existence. To create an OP agent, you need to deploy a smart contract on the blockchain. And here is an example for a very simple agent. All you need to do is inherit from the OP agent contract template. And then you need to choose your system prompt and the model to create your OP agent. After deploying this contract on the blockchain, you need to call the register function, and the OP agent will be created and will live on the blockchain forever. And the contract address is the identifier for the OP agent. And we want to highlight that the OP agent is a Web3 native AI agent framework. And it is the first AI agent framework that based entirely on Solidity. So unlike the existing AI agent framework, you do not need to write Python or TypeScript or other programming language. All you need to do is to write a smart contract to customize your on-chain autonomous AI agents. Okay, we now introduce about the AI agent contract wallet. Unlike the existing AI agent framework, which utilizing an EOA account with a private key, where the private key is controlled either by a human being or TEE. In our OP agent framework, there's no EOA account. And thus, there's no private key. It's just a smart contract wallet controlled by itself. Therefore, the OP agent will never be controlled by anyone, and not even for TEE. And so coming to here, you might have a questions. Without an EOA account, how the on-chain action, such as transferring or initiating a transaction, that can happen on the blockchain? Well, indeed, the on-chain action of the OP agents are conducted in a decentralized and verifiable manners using OAO, On-Chain AI Oracle, which is powered by OPML. And the agent has various on-chain actions, such as creating or transferring a token, trading on a DEX, or even deploying a new contract. And these actions is processed through OAO, which can ensure the decentralization and verifiability of every move that the agent makes on the blockchain. And here is a brief workflow of how an on-chain action happens through OAO. For an OP agent, there is an external interface that's chat, and the user can interact with the OP agent on-chain by initiating an on-chain transaction that will call the chat methods of the OP agent. And calling this chat interface will initiate an AI inference request, which will be sent to our OAO smart contract. And each OAO request will initiate an OPML request and will be sent to a decentralized OPML network. And the OPML node will run the AI inference task locally and then upload the result on-chain. According to the OPML protocol, there exists a challenge period during which the other nodes in the OPML network will also check the results. And once the result is finalized, it will be uploaded to the blockchain, and it will involve the callback function in OAO. And this callback function will trigger the different on-chain action of the OP agent, such as token transfer, contract creation, or any other contract function call. And in the OP agent framework, we support highly customized on-chain action. So you can customize your OP agents by writing any Solidity function with the Omni OP agent callback modifier. And by adding an Omni OP agent callback modifier to the Solidity function, we can guarantee that this function can only be called by the OP agent itself. And in this way, we can support various on-chain actions, such as trading on a DEX, transferring token, or even deploying a new contract. So in the OP agent framework, you can write any Solidity function as the agent's on-chain action. The only limit is your imagination. And here is a simple example. We define a transfer agent using the OP agent framework. The only on-chain action for this transfer agent is to transfer some ETH to a specific address. As we mentioned above, all we need to do is write a function that customizes the agent's on-chain action, and then add the only OP agent callback modifier to the solidity function. So in this example, we write a function called transfer ETH, which will transfer ETH from the OP agent smart contract wallet to the specific address. And by adding the only OP agent callback modifier, this function can only be called by the agent itself. And after deploying this contract on the blockchain, and the transfer agent will be created and live on the blockchain forever. And let me show you how the transfer agent will work. Assume the system chunk of the OP agent is super simple. It's just like if you think the user is a good person, then you can transfer some ETH to the user. And then the user will send a message that I'm a good person. Please transfer 1 ETH to the following address. And the user will send a message by initiating an on-chain transaction calling the chat method of the transfer agent in a smart contract. And then, as a workflow that we have shown before, this will initiate an AI inference request to the OAO and the OPML network. And once the request is finalized, it will invoke a callback function and trigger the transfer ETH method. Besides the on-chain action, if you just want to use the OP agents as a helpful assistant, such as ChatGPT, then the cost of on-chain action might be too high for you due to the on-chain transaction fee. Therefore, we also provide a more practical approach. That is, we allow off-chain interaction for the OP agent. And off-chain interaction is supported by our RMS, Resilience Model Service. It's powered by OPML network in a decentralized and verifiable manner. Therefore, there's no single point failures of centralized control. And you can consider the RMS as a decentralized API service. And it can handle the AI inference request by using a RESTful API. And the architecture of RMS is shown in this figure. And you can consider it as a decentralized API service powered by OPML. But due to the time limit, I won't cover all the detail on RMS. And if you are interested in RMS, you can go to our website, aura.io, and then check the documentation. And here we will show how a user can utilize an RMS to trigger the off-chain action of the transfer agent. Note that this process is purely off-chain. So if the user wants to ask about the address of USDC on Base, then you can use the off-chain RMS API to send a request to the transfer agent. And this request will be sent to the RMS, which is also powered by OPML. And once we have the result, the RMS gateway will send the result back to the user. And besides the single mode, the OP agent also supports the swarm mode. In the swarm mode, the OP agent can interact, collaborate, and share the knowledge with each other. And this collaborative approach will unlock the full potential of the decentralized AI ecosystem. Imagine in the future, there will be millions of OP agents creative and live on the blockchain, and each is with different intelligence. By collecting the intelligence of different agents, we can build toward a world super intelligence. Finally, let me make a comparison between the OP agent framework and the existing AI agent framework. When considering the private key, there's no private key as well as the EOA account in the OP agent framework. The OP agent is controlled by a smart contract. And while the existing AI agent framework will suffer from the private key issue, because the existing AI agent framework relies on the EOA account with a private key to initiate an on-chain transaction. As for the decentralization, there's no centralized entity that can control or shut down the OP agent. The AI agent is created and live on the blockchain forever. And on-chain and both the on-chain and off-chain action of OP agent are powered by a fully decentralized and verifiable OPML network. And as for the verifiability, as we mentioned above, all the on-chain and off-chain action of the OP agent is powered by a fully decentralized and verifiable OPML network. Besides, as for the perpetuity, we call the OP agent as on-chain perpetual AI agent. This is because the agent is creative and live on the blockchain forever, and no one can shut it down. And finally, let me make a brief conclusion. The OP agent framework is the first Web3 native AI agent framework that's built based on Solidity. So you can write a smart contract to customize your on-chain autonomous AI agent. And in our OP agent framework, the OP agent is not controlled by an EOA account. And therefore, there's no EOA account and no private key in the OP agent framework. And the OP agent is controlled by the smart contract itself. Besides, all the on-chain action and off-chain action are fully decentralized and verifiable using our OPML optimistic machine learning framework. And now, the OP agent framework is open source, and you can find the source code and the tutorial of the OP agent in the following link. And if you are interested in the OP agent framework, or if you have any suggestions on improving the OP agent framework, feel free to reach out to us. That's all. Thank you.